Now I will read the instruction for you. The instruction here, together with the team, help the ship to reach the destination. So in short, we will go on a trip. Here's our objective for this activity: to determine how vectors can represent distances and directions, to demonstrate how to use vectors and understand directions, distances, and times associated with the movement and speed.
It will be 8 square units to the west on the first month. It will be 8 square units to the west on the second month. It will be 8 square units to the west on the third month. It will be 8 square units to the west on the fourth month. Then it will land on USA within 4.3 months.
Your ship can sail 8 square units per month. Unfortunately, the wind does not always blow the way you want. To determine how the wind affects our travel, let's include the wind vector. Now at the end of the vector, add the wind vector using the blue marker. First month wind vector is 1 square unit south. That's where you are when the first month ends. Now do the same for the next month and the month after that until you reach the land. For the second month, count 8 square units. Remember that the wind changes, so each month you will have to add a different wind vector. Second month wind vector is 5 square units southeast. Repeat the procedure, count 8 square units. For the third month, we have 1 square unit west. For the fourth month, count again 8 square units. And then we have the wind vector for the fourth month, 1 square unit to the north. And then count again 8 square units for the fifth month to reach the land, and then we have the remainder 2 square units to reach the land. Where will you make landfall now? Of course, we reach the land, United States. How many months to reach land? We will only count the solid 8 square vectors. It takes 5.2 months to reach our destination.
Welcome to our part 3 of our experiment, Vector Voyage. Remember in the part 2, we included the wind vector. In this part, we will include the wind and the ocean vector. Before we proceed, let's first identify the given. The ocean vectors, we have 3 square units south, 4 square units west, and 4 square units southwest. In the wind vectors, we have 1 square unit south, 5 square unit southeast, 1 square unit west, and 1 square unit north. And the ship's vector is constant with 8 square units west, Our expedition will start here at Spain. Get the shift vector counting 8 square units per month using a red marker. Add the wind vector with 1 square unit south using a blue marker. Then add the ocean vector with 3 square units south using a green marker. Do this each month until you hit land. Remember, the wind and the ocean vectors are different for each month. Now, let's continue. Add the ship's vector again with 8 square units west. Then add the wind vector of 5 square units southeast. And for the ocean vector, add 3 square units west. Next month, add square units west again. Add 1 square unit west for wind vector. Then add 4 square units southwest for the ocean vector. Next, add 8 square units west again for the ship's vector. Add 1 square units north for the wind vector. Since we don't have the fourth ocean vector, the remaining units were marked as ship's vector until it will hit the end. So we're done now. We will now able to answer the given questions. Where will you make landfall? It didn't landfall in the given figure. How many months to reach land? Unknown, because it didn't hit the land on the given map. In this figure, we combine all the vectors in just one worksheet.
Generalization. What you have observed in the experiment. We observed that the ship's direction can change if we consider the ocean current and the flow of the wind. Application. Based on the activity you perform, what are some importance of using vectors in our daily life? The importance of using vectors in our daily life is when we search for a place in a map, calculating the place where you start to the end, and the direction that are going to take.